Today, we will discuss a sample problem related to earthworks. In this example, we will determine the volume based on given cross-sectional measurements using the end area method. First, we determine whether the section represents a cut or a fill. For station 4 plus 400, the first set of values represents the elevations, or the vertical components of the section. The presence of a positive sign indicates that the ground is above the road base. The second set of values represents the horizontal components, or the offset distances from the centerline of the road. Now, let's illustrate the first given cross-section at station 4 plus 400. We begin by plotting the centerline at 0 for the section, with a corresponding elevation of plus 1.20. Next, we plot the right offset at 5.20 meters from the centerline and assign its elevation of plus 0.80. Then, we plot the left offset at 9.80 meters with an elevation of plus 2.65. After plotting all the points, we draw the terrain by connecting them above the grid. Next, we incorporate the given road base width of 8 meters into the illustration. From there, we draw the trench lines, from the left offset point to the left edge of the road base, and similarly from the right offset point to the right edge of the road base. With this, we can now clearly visualize the area that needs to be excavated, as represented by the highlighted portion. Now, we divide the cross-section into segments. To do this, we first draw a line from the left trench to the centerline of the road base. Then, we draw another line from the right trench to the centerline. After dividing the section, we label the resulting areas as A1, A2, A3, and A4. Now, let's determine the area of each segment, starting with A1. From the illustration, we identify its base and height. Using the area formula for a triangle, A1, it is equal to 1/2 times its base, 4 times its height, 2.65, which gives 5.30 square meters. Next, for A2, the base is 9.80 meters and the height, based on the grid, is 1.20 meters. A2 is equal to 1/2 times base, 9.80, times height, 1.20, is equal to 5.88. For 3, the base is 5.20 meters and the height is 1.20 meters. Thus, A3 is equal to 1/2 times its base, 5.20 times its height, 1.20. The area for A3 is then 3.12. Lastly, for A4, the base is 4 meters and the height is 0.80 meters. It is equal to 1/2 times the base, 4, times the height 0.80. The area for A4 is 1.60. Adding all the areas, we obtain 15.90 square meters. Next, we follow the same procedure to determine the area of the second cross-section at station 4 plus 420. From the first row of given values, which represent the vertical components, all values are positive, indicating a cut section. We begin by sketching the grid and plotting the centerline at 0, with a corresponding elevation of plus 1.00. Then, we plot the right offset at 5.30 meters with a vertical value of plus 0.70. Next, we plot the left offset at 9.20 meters with a vertical value of plus 2.35. After plotting these points, we illustrate the road base to visualize its width on the grid. Then, we draw the terrain by connecting the top points of the section from left to right. Next, we draw the trench lines, from the left top point down to the left tip of the road base, and similarly from the right top point to the right tip of the road base. Finally, from the highlighted area, we divide and label the segments of the cross-sectional area as A1, A2, A3, and A4. To divide the cross-sectional area into segments, we first draw a line from the left top of the terrain to the centerline of the road. The same at the right portion. After dividing the section, we label the segments as A1, A2, A3, and A4. Now, we can compute the area of each segment. For A1, it is equal to 1/2 times the base, 4, times the height, 2.35. A1 is equal to 4.70. Then, for A2, which is equal to 1/2 times the base, 9.20, times height, 1. It is equal to 4.60. Next, for A3, it is equal to 1/2 times the base, 5.30, times the height, 1. A3 is 2.65. Lastly, for A4, it is equal to 1/2 times base, 4, times height, 0.70, which is equivalent to 1.40. Adding all the segments, the total cross-sectional area is 13.35 square meters. Now, to visualize the computation of the earthwork volume, we illustrate the two cross-sections. From the illustration, we have already determined the first cross-sectional area, A1, and the second cross-sectional area, A2. The distance between the two stations is 20 meters. Using the end area method, the volume is equal to L over 2 multiplied by the summation of A1 and A2. Substituting the values of A1, A2, and L, we obtain a volume of 292.50 cubic meters. Therefore, the volume of the given earthwork is 292.50 cubic meters. And that completes our solution for this earthwork volume problem using the end area method. Try solving a similar problem on your own to reinforce your understanding. Keep practicing, and I'll see you in the next video.